Hello and welcome. This is Jim Kaufman with Rankin Technical College. This video is about how to create and use classes. And this will probably be like part one of multiple parts for this subject, just because there's a lot of complexity around objects and classes. There's a lot to discuss. So this kind of will be the first part of that. And we'll just see how far we get here today. So let's start out. So object-oriented programming concepts. So C# is an object-oriented programming language, right? It's not the only one. There's other ones as well, such as Java, etc. And object-oriented programming, what it does is organizes the code around objects. So it's self-contained units that bundle data and behavior together. A class is a blueprint that defines what properties and methods an object will have. Okay? An object is a specific instance created from that class. I know we've talked a little bit about that before, but we haven't really got into anything more than just the basics. So basically, instantiation. So instantiation is the process of creating an object from a class. You use the new keyword, right? This new keyword to instantiate an object. Okay. Encapsulation. Okay. These are all object-oriented programming concepts, and there's others as well, but we're just going to touch upon these at this point. So encapsulation. Encapsulation is about hiding the internal details of how a class works. So you can call, we've used this before. I know in some of our assignments, convert to int 32, or we converted to a double. We did the try parsing. So, we can use these different system classes that the C# language has without understanding all the details behind it. We just know we want to do something with something, and we can use this to do that, right? To do a conversion or whatever. Try to parse something and then convert it, etc., right? And many other things as well, okay? So we don't have to know how everything works, okay? Now, from a real-world perspective, right? So let's just say we're building classes and objects about cars, right? So, and a car has an engine, right? So a lot of people, when they go to their car, do they understand how all that works? Most people don't, right? So when you turn the key to the ignition, or you push a button, or even nowadays you can voice activate, tell your car to start, right? So, what really happens? Well, there's a bunch of stuff happens, right? The ignition switch sends a small current to the starter relay, then connects the battery to the starter motor. The starter motor spins, and the engine's flywheel gets the pistons moving to draw in fuel and air, while the ignition system creates a spark to ignite the mixture, allowing the engine to run on its own, right? So there's a lot going on there, and most people, they don't care about it, right? They just want to be able to go out and turn the key, push the button, or tell their car to start, right? So in a way, all of that is kind of hidden, right? So that's kind of the concept of encapsulation there, kind of from a real world perspective and not just a coding perspective, okay? And also we have what's called inheritance. So inheritance is a class can be based on another class, right? Gaining its property and methods while adding its own, right? So when a class inherits, and we'll learn how to do that here eventually, how we can inherit one class from another class, okay? We, like in a real world situation, here, let me show you. I've got an example up here. So here, this is a simple diagram. And this is kind of called a class diagram. Very simple one, more of just a handwritten one, right? But this is an inheritance diagram where it's saying sedan, right? Inherits from car, right? Wagon. So these are different kinds of cars: sedan car, wagon. This is probably more of a traditional name. It used to be like station wagons and stuff, but they still call them like crossovers and that. Some of them still called wagons, right? Or Formula One race car, right? It's a car, right? But it's going to have different properties. It's going to have different kinds of engines. It's going to have lots of different things with each, right? But they're all going to inherit from a basic car class, right? And they're going to have some of their own specific things that only are associated with that specific type, right? But this is basically a simple little inheritance diagram, okay? Here, yeah, and real quick here, back to this. So basically, even car, you can have multiple. In the real world, there's multiple levels of inheritance, right? So a car is what? A car is a type of vehicle, right? So even a bicycle, a motorcycle, a boat, right? All of them are different types of vehicles as well, right? So cars does inherit from vehicle, right? Well, a boat would inherit from vehicle as well, right? So there's usually multiple levels of an inheritance, right? And we'll learn more about that as we move forward. Okay, and another concept is composition. Okay, so building complex objects by combining simpler objects as fields. For example, a car class might contain an engine object. Okay, so let me see here. So here is an example of composition. Okay, where a car has a wheel. It has four wheels, right? Car has wheels, right? A car has an engine, right? A car has one or many seats. And we'll learn what all of these kind of mean. These are special these do mean certain thing in what's called UML diagrams, okay? And we'll learn what all of this means. But this basically says a car has wheels, right? A car can have one to many seats. That's what this means, one to many seats. So you could have a 2-seat car, you could have a 4-seat car, right, etc. A car is only going to have one engine, though, right? Now, other vehicles, so we talked about there could be other vehicles, so like a bike, right? A bike could have 2 wheels. You could have also a bike with 1 wheel, right? Or a bike with 3 wheels, a tricycle, right? So, in this case, a car's, generally always going to have, well, I shouldn't say that. There are cars that don't all have 4 wheels, right? But, most do, okay? All right. But the important thing really here about composition is has a relationship, right? So a car has, many wheels. A car has engine. A car has many seats, right? One or many seats, right? So like in a Formula One race car, you only have 1 seat, right? All right. And then, so has a for composition, right? Is a relationship for inheritance. Sedan is a car. A wagon is a car, right? What else did I want to say? A little bit more about composition. And, I know these are new concepts to most of you. And, with something within time, you should really, by the time you get done with this program, is have a pretty good understanding of all the different object-oriented programming concepts and be able to explain them, okay? I did want to mention something like there's different kinds of composition. Like there's kind of called like weak and strong. So like certain things, like can something exist without the other thing? Okay, so let's just say use a house for example, right? So if we have a house and a room, right? A house has a room, right? Now, if you tear down that house, you're not going to have a room no more. So that's a very strong relationship, right? You have a very strong relationship there. Without that house, you have no room, right? Now, maybe a car and a wheel, right? So if you don't have a car, could you still have a wheel without a car? Yes, you could, right? So that's a little bit of a weaker type of relationship, so to speak, right? Whereas at a house, you're not going to have a room. You have a house. Without that house disappears. You can't have a room, right? Now with a car and a wheel, that'd be a little different. You could have a wheel, right? A wheel without the car. All right. All right. So let's talk about a little bit about three-layered architecture. So well-organized applications separate code in different layers, generally 3 layers. So you have your presentation layer, right? The user interface is what the user sees and interacts with. And in our case, we're using WinForms, right? WinForms are MAUI apps, right? But your WinForms is your forms.cs file, right? And that's your presentation layer. Then your middle layer is your business logic, and these are the rules and that calculate your application, and these would be like your custom classes, but also you do have your form .cs file that you generally use also. I mean, that's how we've kind of been building a lot of our logic is within the button click events. It's just a little different because WinForms kind of wires everything together for you. But your middle layer, it's best to have some things separated out, right, and not depend on each other. Okay. One thing with our WinForms, there's a lot of dependency there with them, but we can have our custom classes as well. Okay. Here's just talking about pet.cs. That's because we're going to be using a class for demonstration purposes called pet. And then the other layer would be the database layer. And this is your data storage and retrieval, right? So this is code that reads and writes to a database or file. Now, initially here today, this week and that, we're not going to be using databases. We'll be doing a little bit of database stuff more at the end of this course. But, this course is more about C# fundamentals, okay? Just the programming fundamentals more than just database stuff. But, we will spend a little bit of time on database stuff. But then we're basically from a 3-layer architecture, that's the basic different layers, right? Presentation layer, right? That's what the user interacts with. The middle layer, right? This is what a lot of users of applications, they don't know what the middle layer is. They don't know, right? But from a developer standpoint, you understand that's where your business logic is, right? And then the database layer, that's where your data is stored and retrieved, etc. Okay. Let's see. Key distinctions. So this kind of really, belongs more to the object stuff. So two objects created from the same class share the same fields, methods, and properties, okay? But each holds its own data. So that's what it's really all about when we talk about objects and classes. So classes, the classes are the blueprint, right? The class is the cookie cutter, right? The cookies themselves are the objects, right? So, each object, when you instantiate an object, it's going to have its own data, right? So think of a class as like, all right, look at this class as a cookie cutter and object as cookie. They have the same shape, different sprinkles, right? Different data, different things. All right. So reading UML class diagrams. So let's talk about what UML is and go from there. So first, let's talk about OMG. So OMG is a standards body, okay, and they create a bunch of different. They have a bunch of different standards, and one of the more popular ones is UML here. But I guess we should go over this a little bit. So since its inception, the Object Management Group, OMG, has been the forefront of shaping the technological landscape by establishing and redefining or refining industry standards, founded with a singular vision to create a framework for technological advancements. OMG has evolved into a powerhouse of innovation and collaboration. Whether you're soaring through the skies, navigating diverse terrains on land, exploring the vastness of space, are delving into the depths of the ocean. Our standards accompany you in an expansive world of technology. So they have a lot of different standards, a lot of different establishment and industry standards. Okay. So if we come down here a little ways, you'll see that some of the more popular ones that they have different standards and for innovation. Okay, and they're in a alphabetical order. The one we're going to do is kind of the one at the bottom. It's UML, and like I said, it's in alphabetical order. Not that it doesn't mean it's much because it's at the bottom, right? It's been around for a long time, actually though. So here's UML. Okay, and this is the Unified Modeling Language. Okay, so you transform your designs with UML, access resource, and basically within the website here, there's certifications, there's tools, etc. Okay, so an introduction to the Unified Modeling Language. So let's just look at UML frequently asked questions. So what is the Unified Modeling Language? UML is a language for specifying, visualizing, constructing, and documenting the artifacts of software systems, as well as for business modeling and the non-software systems. Okay. The UML represents a collection of best engineering practices that have proven successfully in modeling of large, complex systems. Okay. So there's a lot of companies and organizations that support this. It's very well used and supported by multiple other companies as well. Let's see, what else do I want to look at here? It's a good idea to come out here, take a look at a little bit of things here. All right. So just kind of want to point that out. Okay. So these are there's different types of diagrams. Okay. And one of the types of diagrams are class diagrams. So for our different assignments, some of our different assignments, starting here with chapter 12 of that, you're going to have to build your code based on class diagrams. Okay. So here's an example of a diagram for a pet class. Okay. And so what I'm going to do here, I really like this functionality here. I'm going to add a tab to split view so I can show the diagram and the explanation at the same time here. Grab this and drop that there. That didn't work because I put it in the wrong spot. Huh. Let me just do it this way. I messed that up by accident there. All right. So I'll do that. And here's the meaning. Maybe we'll do the pet. And here's the meaning. Okay. So this top portion is where you have kind of your variables, right? So in this case, you got a pet class. So and this is what you're going to kind of see in the real world too. Depending on the organization and stuff. Usually, as a programmer, you have a requirements document. You'll have a class diagram. You'll have to be able to create code from this, right? And so here it's usually it's going to be like an architect or senior person that's going to give you this, right? Or create this. And so the top parts are your different variables. And when you see this dash at the beginning, all right, when you see that dash at the beginning, that is basically meaning the minus sign it means it's private, only accessible inside the class. Okay, so whenever you see a dash here or minus sign, what you're gonna know to do is you're gonna use private. You're gonna use the keyword private before the name, right? And obviously you have to include the type as well, right? So your access control will be private. You're going to have a type, right? And this type, it's telling you, right? It's going to be a string. and then and you know the name of the variable, obviously. The plus sign. So if you have a plus sign, and it's possible that your variables could also be public. A plus sign is for public. It's accessible from outside the class. Okay. And I'll show you a little example where how you can see, well, oh, can't access it. We change it to public, and you can. Okay. So I'll just say in the top section, these are the fields, and these are also called instance variables, right? The data the object stores, right? So every time you uh, instantiate a class, right, it creates an object, right? An object is an instantiation of a class, and each object's going to have its own set of data, right? It's going to have copies of everything that's in here, right? When you create an instance of a class, it's going to have everything that's in here, but the data will be different based on whatever you set it. Okay. So usually you have this a middle section, right? It's usually constructors and methods right here. So right here you got a pet. So this name here, a constructor, if you see a method, right? This is a certain kind of method. This is called a constructor method, okay? And here it's got your constructor is going to have can be a default constructor. It would have just open and close parentheses, or it could have parameters. Okay, in this case, it has all the parameters that are part of this pet class, right? Your name, your species, and your age. Okay, or not your age, the pet's age. And then also we've got some methods here as well. So these are all plus signs, right? So these are all public. So generally, to be able to access anything in something has to be public to gain access at all, right? So usually you have some methods for getting the name, right? And so getting the name, getting the species, getting the age, and here I have and sometimes you have other methods as well. So it's very popular to have methods for getting and setting things, right? But you can also have other methods that do something, right? So you on your object, right? You can have your object name. Say you have a new pet, right? And your new pet instantiates the pet class, right? Instantiates an object. Then if you do that dot have had birthday, it's going to add to the age, right? And we'll take a look at an example of that, right? But basically, to create a new pet based on this class, you're going to have to use this pet, which is constructor, passing in a name, a species, and an age. Okay. All right. So once again, yeah, the colon string after the field name. This is the data type of the field, right? And then here, when you've got, okay, get age, when you've got this like open and close parentheses, you have the int after a method name. This is a return type of the method, right? Public int get age, right? If you had arguments you're sending to it, it would be within the parentheses here. When you're doing a method and you see it in like this, this is basically the return type, right? This is saying void, right? Okay. Let me get rid of that. Creating a class file. So we're going to go ahead and do that right now. I'm going to just actually, this is kind of a, this is basically the complete class file. This is the complete class file based on our UML diagram here. Okay, this is what that will look like. Okay, but I'm going to create a little bit more of a simpler one here. Okay, so let me do that here. Okay, so I just have a simple form here with a button, get pet. Let me add a label here. And this label, what I'm going to do on this label, let's call this label result. not sure if you've done any of this before. You can do this border style stuff if you want it to kind of stay there, and you can make it bigger, and it's kind of much better for when you're gonna have you're gonna populate it with multiple different things. So I'm gonna do that. Oh, and then also I need to change our auto size to false. And I'm gonna make this as big as I want. I'll put it down here because I'm gonna do some other things up here as well. And then in here, I'm gonna go ahead and get rid of the text. All right, save that. And I think I already have my button click event from before. Okay, so next thing I'm gonna do is come in here. I'm gonna create a pet object. So I'm gonna come down here, add class. So, and then in here, this pop-up will be, you can create different things, right? By default, probably most of the time when someone comes here, they're creating a class, but it depends on what you're doing, right? There's other things you can create as well. We will do some interfaces in the future, but for right now, we're just going to do a class. And then so in here, we just go ahead and do pet.css, click add. Okay, so that created this basic scaffolding for the pet CS, and it's an internal class. So by default, it's going to create it as internal. So internal basically means used within this project. Sometimes you might have some classes, you're creating a library or something, and you want it to be accessible by other people can call it into their programs, into their projects. Or if you've got, or you could create some classes for one project and then you wanted some other project wants to call them in, right? So you would make it public instead of internal. But for our purposes, we're just going to keep it internal, okay? And then here, I'm just actually going to grab, let's see here. I'm going to grab these three right here. So I'm just going to do a simple one, okay? And then we'll drop all this other stuff in here and look at that as well. So just having this by itself. So what happens though, and you'll see here in a minute, all we do is we have these instance variables. These are called instance variables. They're all private as well, right? So if we try to, but by default, every class you create is going to have what's called a default constructor, right? And that's the way how you instantiate an object. Use the new keyword with your default constructor. You can have a constructor that's a default constructor, or you can have one with parameters, right? So if we went back and looked at our here, this is a different constructor. This has parameters, right? You can use this, okay, to create an object, or you can create one with the default constructor. And let's kind of take a look at that a little bit. So I'm going to open up my button click event here, and I'm going to do pet here. I can call it my pet equals new pet. Okay. As you can see, there are no red marks, no issues found. It's happy, right? Now I have my pet. This is where we're going to run into a little bit of problem. So let's see, my pet dot underscore, right? Like name, right? That's what we called it. Equals, and what's this going to tell us? Pet name is inaccessible due to protection level, right? So we can create this using this default constructor, right? But since we made it private, we made those instance variable private, it doesn't have access to them, okay? So if we want to create a new one, right? So here, let's just do this real quick. So I'm just going to make this one public right now, okay? It's really best to make them private unless there's a reason to make them public, okay? So now I'm going to come in here. All of a sudden, It's good. It's happy, right? Because I made it public, it has access to that now. Okay. And then you could just give it a name here, right? All's good, right? But we want to, like I said, it's probably preferable to make them private. So we're going to do some things a little bit different here. Okay. So let's go ahead and drop some of this other code in here to make things simpler. So we're going to create that constructor that we've seen before, right? And that's part of our class. All of this will be part of our class. So usually at the top, you're going to have all your variables, and these are called the instance variables, right? So here's that. And then we'll just leave it like right there like that for now. So we have a name, species, and age. No issues found. Everything looks good. It's happy with this, right? So just remember your constructor needs to be public. Okay. There's some specific instances where you have a private constructor for most of the time, but to create instances of something, it needs to be public. Right. Now let's go back to our code. All right. Now all of a sudden we got this little red squiggly under here. Well, why is that? Well, what happened, like I mentioned earlier, once you have a default, once you create a constructor with parameters, the default one is no longer there. Okay. So if we still wanted to use it, we don't have to use it, right? But to actually continue to use that, this is what you could do if you need it. Okay. We could just do that, open and close, right? And now we have our default constructor, right? Obviously, it'd be best for this to be like that, but that's fine, right? And here you could actually set some things, right? You could set some things. But now if I go back here, I'm just kind of making a point, and my biggest point is to understand is by default, even if you didn't include this in your class, remember we just had these at the beginning, and we went ahead and created that, the code didn't complain in our form.cs file at all, right? When we did a new pet like that, because it's hidden and it's created, it's there by default, okay? But once you add another constructor, okay, with parameters, right, then you have to actually explicitly go in here and add it, okay? I'm just making a point more for your understanding. And now, since I added it, it's good, right? But for us, what we'd really like to do is pass in some data here, right? So for us, let's go ahead and let's go get back and let's get rid of this. We're going to stick with this constructor like this, okay? And then we are going to, just for sake of time and that. All right, so this is good. No issues found. This is happy. We're going to come back in here. And instead of this, we're going to go ahead and create some, we're going to pass in the parameters. First name is Max. He's a dog. He's 1 year old, right? And so now we have our date. We have an object, right? But what can we do with that, right? So if I come in here, and usually, with the auto assist stuff, usually it'll tell you, like before, you type in things like my pet, right? And then you put a dot here. Well, you have things here, right? But it's better to be able to let me see something here. I just want to check. Yeah. So you can do things like this, right? But this is just going to set a variable. What if you want to get the data? You created this data here. How do you get this data, right? So you can use those different getter methods. So let's just do one for get name here. All right, so let's go back to our object here. So now we've got our constructor. And then here, let's do our get name. All right. And our get name gets the name from here, right? Underscore name. So the underscore really means this is local, okay? And later I'll show you. So a lot of times, okay, so like in this constructor, you got name. So what's very popular is usually not to call things differently. Usually when you have a constructor, you're going to you're going to define these as the same name that are up here, except you don't see the underscore. But if you had this as just name, right, then this here is not going to work for you, right? Name equals name, it doesn't know. The only way to get around this, now you can do that and get rid of those underscores, but then you have to do what's called this, right? And you're basically saying this name, right? This one, if I double click on this, it highlights up here, right? Because it's going to find that one, right? Because this is the instance, right? It's basically saying find me the instance of this object, right? And that's this one here. Okay, this refers to this one. This dot name is going to refer to this one. Okay, now just a simpler way, maybe less confusing way, easier, is just to call it a little something a little bit different there, right? And let me put that back here. All right. Okay, so now we have get name. So if I come back over here, if I want to get the name of my pet, I can do my pet, right? Dot get name. And you can get the name of that now, right? And so let's just say I want to kind of set that on my form here real quick. Let me just grab this to make life easier for me. Now let me get rid of this. So I'll write inside the code here, right? I'm just doing my pet.getName, right? Let's just save this. So we'll see it. Let's run this form. Okay, hit get pet, name equals max. There you go. Okay. All right. So now let's go ahead and add some of these other ones as well here. So we had get species, get age, and also, yeah, let's just do those two. Let me get into the right one here. So these are called your getter methods, right? So you have getter methods, and then you also have a constructor, okay? Now you can also have setter methods as well, okay? We'll kind of look at that here as well. But, you know, for us, we're actually setting things based on creating a new thing. So this is something, you know, we kind of know ahead of time what the values are, right? You're basically building, you're creating your objects based on data you know coming in here, right? All right, so now we have that. And so now, if I come back here, I can kind of do all of this now. Which I'm going to do get name, get species, get age. All right. And actually, we can get rid of these commas. So, and we're doing the, you know, \n is basically a new line character. I'm not sure if you guys done that yet. I think you have, or some have. So basically, it's just going to put it on a new line, right? Within the window, like the label that I have. So let's go ahead and run this, see what this looks like. So we have this get pet now, and then you've got name max, breed dog. Actually shouldn't be breed, age 1. Should be species. All right. So now we have that. So the next thing I'm going to do is just go ahead and drop that other one in here, and that's basically the has a birthday, right? So this method modifies the data. Okay, it's going to take the age, it's going to add 1 to it, right? Plus plus, it's going to add 1 to our age here, right? That looks good. All right. And so here what we're doing is, we got Max. Max is 1 year old. And if we do my pet here, and if we do a dot, had birthday, open and close. So now when we print this out, the age should be 2, right? So let's do that real quick. Get pet. Now the age is 2. There you go. So now we can do multiple ones here, though, right? Let's just do another one as well. So one thing is you can't use the same name, right? Actually, this one's going to override this one, but that's okay. And something, when you play with this, this is one thing you got to be careful that you always update your ones so you don't print the same thing twice. And also, you put these things in collections as well. So we're going to look at that, okay? And then it's a second dog, right? So this is a situation, right? Like just what we were talking about before, when we, they all, both of these, both My Pet and My Pet 2 has all of those different properties, right? And methods. It has all of those. It's just the data is different, right? Obviously, you could put the same data here, right? You could put the same data here, and they would have the same data, but in a way, they're still considered 2 distinct objects. They're stored in different places in memory. Okay, even if they have all the same data, all the same methods, every time you do a new keyword for an object and you create a new object, every time you create a new object, it's going to be in a different place in memory, right? It's going to have its own unique location in memory. Okay, so we just kind of looked at this. So fields, these are our instance variables. I kind of went through all of this. These are our instance variables, right? Here's our naming convention. Private fields in C# typically start with an underscore, okay? This helps distinguish them from parameters and local variables. Getter and setter methods. So since fields are private, you need public methods that let outside code read or change those values. A getter returns the field's value. A setter accepts a new value and assigns it to a new field. Okay, so just for fun here, let's just add that. Let's add that one to our code here. So there's our getter methods. I'm going to add this setter one. So we got a set name now. So let's just say we create our object and later on we need to, we need to reset it to something else, right? So let me get rid of this one here. And so then here, let's just say we call them Max. Nobody liked the name. And we decided to rename Max, right? So we can do my pet here. Dot set name, right? And we can give him a different name. Kind of name we want to give him. I don't know. Coco. Right? So we create a new instance, and then we ended up wanting to, we needed to change something, right? So we're using the set name to change that. Now if we run this, get it, right? And then it updated his name. Okay. So now there are different ways of doing things, which kind of, you know, basically the old traditional way. The old traditional way was always using those like get, set, that. So properties the C# way. C# provides properties as a cleaner alternative to getter and setter methods. A property looks like a field to the outside world, but uses get and set accessors behind the scenes. Okay. So we could do this. So let me go ahead and change that. So let me get rid of this setter. Get rid of this. All right. So basically a get is going to return underscore name, right? If you pass in a variable, all right? If you pass in a variable, right? This value is something you're passing in. So let's just kind of look at that real quick here. Set name's no good anymore. So let's see what we can do here. Dot name, right? So if you do it like this, all right, you pass in a variable, right? Or actually, I'm sorry. I don't know what's doing there for me. Yeah, I apologize. I was incorrectly thinking. So whenever you do like equals this, right? Then it will go ahead and set, this is the value part, right? Well, here I had Max there. Let me do Coco, right? So then you can do my pet.name equals Coco, right? Or to get it, right? You can do just what? Dot name. Okay. So a different style, right? Whenever you do a dot name and you've got an equal sign, this is going to be your setter method. This is your getter method, right? This is your getter. This is your setter, right? So let's see that, make sure that works. Yep, so now it called the setter, and obviously the getter worked as well. So a little simpler, right? A little more condensed there. And then that way you don't have these get that for each one of them, right? So we could change these for all of them, right? All right, let's look back here. Auto implemented properties. Okay, so this is just showing some different options here. So when getting getter and setter, simply return and set a value with no extra logic. Um, so sometimes, and this is kind of based on requirements. Let me go back to the code here. So this is kind of based on requirements. Um, so for a pet, we have a constructor here, right? So maybe you don't want to have a separate setter that they can set things. Maybe you want to force them to create it, and you don't want just somebody coming in and changing one variable here and there. Maybe there's some business logic, some business reason that you want something created. You don't want it to be set again, right? So you don't want this to be there, right? Um, so let's go back and look at this. So in this case, right? Well, this is just a very a simple get and set, right? And this is kind of auto implemented. When the getter and setter simply return and set a value with no extra logic, you can use auto implemented property, right? Creates the backing field for you automatically behind the scenes. Okay. Um, but also this one here, it would be considered a read only, right? Read only, auto implemented, no set accessor. You don't want them to have access to it, right? And then sometimes you may have something where you want to do um, initial value, okay? So you can do this with a get, and this will set an initial value, all right? So special property accessors, read and write, anyone can get or set the value. This one is a read only, okay? This one here is read only, but can be set by a constructor or an object initializer, all right? And then there's also this required keyword, and the property must be assigned a value when the object is created, right? So if you have this required, that means it has to be created, has to be assigned a value when the object is created. Constructor, which we kind of already talked about. So a constructor is a special method, right? It runs when an object is created. It has the same name as the class, okay? So that's how you know by looking at a file which one is the constructor. It has the same name as the class, okay? And it has no return type, not even void, okay? No return type at all. Its purpose is to initialize an object's fields, okay? So all these other methods, remember, you always got to give it a type. It's going to either return a string, it's going to return, an integer, a decimal, whatever, or void, right? It doesn't return anything. Constructors don't have that type at all. And its sole purpose is to initialize the object's fields. So we already talked about this a little bit. If you don't write any constructors, right? C# provides a default constructor, no parameters, automatically, right? However, as soon as you write any constructor, the default one goes away unless you explicitly add it back. And we already looked at that, right? Overloaded constructors, okay? You can write multiple constructors with different parameter list. This is called overloading. So here's you have a default constructor, right? Here's a parameterized constructor with brand and gears, right? But that doesn't mean you couldn't have also a one that you just had public bike brand. You could have a third one here, right? This is your default one. This is one that has two parameters. You could have one that doesn't include gears, which probably isn't realistic, but there's some situations where you don't need all the variables to create something, right? You could create something without having all of the different things. right? So that you could actually have one where you just had brand only, right? So you could have multiple different constructors. So creating objects, instantiation, right? Once you have a class, you create objects from it using the new keyword. There are several valid syntaxes. So the ones that I was doing, right, was the standard syntax, okay? And then they kind of came up with other things as well. You know, it doesn't always make things simpler for people, especially learning. People like it that's been programming a while when they see it. It's, oh well, I can just do this. This is a shorter cut. But when you have different options to choose from, it can be kind of confusing sometimes, right? But that's my take on that. But this is kind of the standard syntax, and this kind of what I was always used to most when from my developer years. Um, Here, well, obviously you don't want to use var. You really should be using something besides that. But okay, that's all right. But using a var for type inferred, right? So this way, because you're using this, you're calling it a new bike, then it already knows that my bike is a bike, right? So it's telling you don't really have to state it's a bike, right? And then the other one is target typed new, type inferred from variable. Since you're saying, hey, my bike is of type bike, right? I don't need to state it again, right? Just kind of a shortcut. Does it save you that much? Not really. That's up to you how you want to do that. But sticking with standard syntax, I just by default I usually do that. But there is other options as well. It's just showing you can't do this. All right. Object instantiators, which we're kind of already did this a little bit. So an object initializer. I said instantiator. Object initializer lets you set properties at the time of creation using curly braces. Oh yeah, I didn't quite. We did the first one. We didn't do the second one, right? We didn't do this way, but it's just another way to do it. You can use the curly braces. You can do your brand equals gears 18, right? You don't have to do the dot notation. This is kind of the more traditional way, right? Or you can do it this way. It's a little more concise, right? My bike equals new bike, right? And then in curly braces, you include your parameters, your properties, I should say. Using objects in your form. Let's see, my bike, that brand. Okay, it's just showing different examples. Yeah, so we already did this, all right? So I'm going to cover storing objects in an array here, and then I think that's going to be it for today. And we'll go, so this is kind of the first part of this. So we're going to have multiple different things we're going to go over because classes and objects is pretty vast. There's a lot involved there. And as far as from our assignment perspectives for this course, we're going to have, some multiple assignments and, there's a lot of different areas that you'll need to understand. So storing objects in arrays. So I'm going to do this real quick and then that'll be about it. So we already have our pet stuff, right? Let's see, .get name to lower. So I think I'm just going to put my stuff back to the original stuff just to make it easier now. Grab that real quick here. Let's go back to the IDE. All right. That looks good. It's happy. No issues found. Okay. I know there will be some errors in here. I expect that. Okay. So in here, yeah, let's just grab this. Why not? Let's just grab all of this. See if this all works. Probably should be pretty close here. Where did the heck search term come from? I'm just going to hard code this in here just to get this done quickly here. All right, so we got this pet count. We'll be doing add a new pet. This is a little weird way to do this. I probably should have grabbed this, but that's okay. All right, let's see what happens with this. Nothing. All right, we'll stop that. So, one thing that's always good you can do is use your debugger, right? Let's walk through this thing. So here, you know, what we're basically doing is creating an array of pets, right? And then the first one's going to be, pet count's going to be 0. It's using that as a thing. So the first one, so it's up to 20, right? You don't have to provide 20, but that's the first one. These are the first two. Let's go ahead and just do this again. Didn't fail though. Just didn't execute. All right, let's walk through this. This is always good to do. Getting in the habit of doing this. So I'm just going to step into, generally never good. Well, it's going to go into a lot of different classes. I usually step over, right? So step over. So we got pet count. So pets is an array, right? And actually down here, you should see all your stuff, right? You always can right click and add watch on it, right? It'll add a watch as well. So here's all your pets, right? So it's going to allocate 0 to 19. So it allocated 20 of them, right? And then here's our first one, and the pet count is 0. So it's adding that one on here. It's incrementing our pet count by 1. And as you can see down here, it actually added a object, right? A pet object. Okay. So now we got, yeah, 2 of them. You know, the first one's how many pets there are 20. Allocated 20. All right. And then we step over. Okay, now we're going to step into this. So our pet count is 2. All right. Pet count I.getName.to lowercase equals buddy. And that's going to be our problem. I can see it already because we're so It's always nice to do this too, especially when you see a for one. So it's kind of nice how you can see it executed this, then it executed this. It doesn't execute this right away. And if you recall when we talked about loops, that this is always executed after your for loop, the first iteration. It's going to come up here. It's going to increment this, then it's going to check this and this, right? So this happens after, So in this case, you kind of seen where it had this highlighted, then it had this highlighted, right? Your initialization, then your condition, your check, right? And then, but your right here, this happen, adding to it happens after, right? So, all right, so here, we're still in here. Step over. And this returns false because get name pets.i.getName.to lowercase equals buddy, because we changed it to lowercase, right? The only way I could fix this very quickly is by changing this to a b, lowercase, and it'll find it, right? So that's what's wrong there. So it's always good. You got to think through these things, right? There's other ways. So obviously what you should have done is had this to lowercase earlier on, and that wouldn't have been a problem. Your search term, because I just hard-coded in there, right? So basically if I come in here, and I think I can still do this, right? Dot to lower, right, like that. Yeah, I'm almost sure I could. So now, because get name to lower was a lowercase b, and so this now should work. So I get pet, it's going to come in here. I'm just going to do continue to get out of here. And there you go. Buddy is a dog. Yeah. This is just one way. It's probably not the best. We'll look at this more in the future. But basically, you can have in the real world, real world example. There's all kinds of real world examples when you're going to have, multiple, an array of things. If you had something where you had all the all the states, right? All the states in the United States, and each one has their own official bird, their own saying, everything else, right? So you had things like that. You have an array of objects, right? So there's many different examples of situations like that, right? So that's all I have for today. There will be some additional videos on different subjects as far as classes are concerned, classes and objects. So please let me know if you have any questions, and have a great day. Thanks.